here initially particles are raised, so the initial velocity the two bodies is 0, and so the initial kinetic energy is also 0, and momentum, initial momentum is also 0. And since the distance between two bodies are infinite, so the initial potential energy is also 0. Now the total energy that is initial energy is kinetic energy, which is 0, and potential energy, which is also 0. So initially total energy is 0. Now the body moves towards each other, and when the separation between the bodies is r, then the velocity of the body which have mass m1 is v1, that is directed towards this direction, and the velocity of mass m2, which is opposite direction, directed opposite to the mass of m1. So from the momentum conservation, initial momentum is equal to final momentum. Initially the total momentum is 0, and final momentum here m1 v1 plus m2 minus of v2. Since v2 is opposite to v1, so m1 v1 equal to m2 v2. Let's say this is the equation 1. Now the total energy of the particle when is at distance r, that is final energy, let's say. So the kinetic energy of m1 mass half m1 v1 square, and for m2 half m2 v2 square. So this is the total kinetic energy, and the potential energy is minus g m1 m2, and the separation between them is r, so minus g m1 m2 by r. Now from energy conservation, initially total energy is 0, and initially final energy is half m1 v1 square plus half m2 v2 square minus g m1 m2 by r. So g m1 m2 by r here multiplied by m1, so this is m1 square v1 square and divided by m1, and for m2 square v2 square divided by 2 m2, so multiplied by 2 in both sides, so 2g m1 m2 by r. This is m1 square into v1 square by 2 m1, and from the equation 1 m2 v2 is m1 v1, so this is also m1 square v1 square by 2 m2, multiplied by 2, so 2g m1 m2 by r m1 square v1 square after 1 by m1 and 1 by m2. So 2g m1 m2 by r equal to m1 square v1 square, LCM is m1 m2 and this is m2 plus m1. So v1 square can be written as 2g m1 square m2 square by m1 square and m1 plus m2 into r. So m1 square cancel, so v1 equal to root over 2g, since here is m2 square, so this can be outside, the root is m1 plus m2 by r. Similarly, v2 can be written as v2 equal to m1 root over 2g m1 plus m2 by r. Now the velocity of approach, that is v approach is v1 minus of minus v2, and since v2 is opposite to v1, so this is v1 plus v2. So the value is v1, the v1 value of v1 is m2 root over 2g by m1 plus m2r and plus m1 root over 2g by m1 plus m2r. So this is root over 2g by m1 plus m2r, this is m1 plus m2, so root over 2g here m1 plus m2 by r, v approach. So the option B is correct.